Good evening, everybody, and welcome aboard. Thank you for joining us on our first virtual technical meeting. I know we're all going through some tough times and some challenging times, and we're maybe a bit WebEx Zoom meetings out, but hopefully you find today's content useful, thought-provoking, and also maybe something you can take away and have a think about. We have quite a few people registered. I see that's still continuing, so hopefully we'll catch up on that. And hopefully this allows us to actually reach out to a wider audience as well. We usually have these technical meetings in Aberdeen on a monthly basis, but maybe this virtual setting might hopefully reach out to some of our members that are a bit further afield or are not able to join us in person. So this may be an option for the future. So if this is some of the format that you enjoy and you like, please let us know, because obviously we're here to deliver a programme for yourselves. And the best way of doing that is making sure that we engage with you, the members, to support that. I'm Rebecca Allison. I'm the chair of the Aberdeen and Highlands Branch of the Energy Institute. So like I say, welcome aboard for the next 45, 50 minutes of presentation. Before I hand over to our presenter today, who is, and we're delighted to have Luca Corradi from the Oil and Gas Technology Centre. So I work alongside Luca with my other day job, or my day job at the OGTC, and Luca is our Innovation Network Director, who has been working very extensively in the energy transition and the net zero future of the oil and gas industry, and his topic that he's going to be discussing today is very topical and, like I say, hopefully insightful for those that are maybe not aware of some of the work that's been going on or just curious. As with all these sessions, we have a Q&A, so I encourage you to drop your questions or comments into the Q&A throughout the presentation. We will be keeping you on mute at the end, just because the number of participants and usually some of the feedback and noise, but any questions that you have, I will be gathering them and posing them to Luca at the end of this session. So please make this as interactive as possible and pose your questions. So one final point just before I hand over to Luca. Big shout out to our technical sponsor of the evening and of the programme, which is Bilfinger Salamis. Without their support, we couldn't deliver some of our programmes, so we look forward to their continued support over the next few months and obviously years to come. And I will hand over to Luca, so over to you.
Thank you, Rebecca, and thank you everybody for taking some time on a Tuesday evening. I'm gonna cover today a bit of an excursus and a walkthrough on the current climate situations, but also talking about how do we get there, what needs to be done, what is actually being done by the various sectors of the economy, including the oil and gas industry, and ending with some reflection on also what is the role of the oil and gas industry in the energy transition, and what is the road to Glasgow COP26, which we'll talk a bit about as well. As Rebecca said, there is a chat function as well, which I encourage you to go to it, because I would like to start with a short question, and the question is, do you know what this is? And if you can put the answer in the chat, we can maybe start seeing if you can use it. And the second question I have while you type the answer to this is, I would like you to start thinking about what is your role. Your role as an energy professional, energy engineers, or whatever other part of the other discipline you work in the world of energy, or the role of your company in the new world, in the energy transition that we're going to talk about. And we keep that discussing for the end of it. So let's see, what are your answers so far? Let's see, histogram, CO2 emissions, yes. So this graph is called warming stripes, and what it represents from left to right, each year, each bar is a year, from about 1850 to today. And the color represents how warm or cold that year has been compared to the average. And obviously the average move, with the new addition. And what you can see here is that, the last 40 years are very red. The last 40 years have been very, very warm here. This is the global average. There are a number of other similar maps for specific places because it's not so uniform. But on global average, the last 40 years have been the hottest since 1850, and they're shifting the average, of course. And so let's take a step back. And how did we get here, right? And so this is a sort of a tale of forward. In the top left, you can see those dots, and those dots are representing emissions. And it starts in the UK, and it starts in the UK with the Industrial Revolution. And you see the histogram there, the bar rising up toward around London, where it started. And this is 1800. So we start the other graph. And we start the other graph in the bottom here, which is also almost in parallel from a time perspective. What you see in the bottom left is the correlation between life expectancy and income. And you can see the various continents with various colors. So Europe is in yellow, and Asia in red, and America is in green. And you can really see that the United Kingdom and the rest of Europe is moving to the right. So they're increasing their income. And that is as a result of the Industrial Revolution that you can see on the top part of the screen, which is growing. And that comes with emission as well. But that Industrial Revolution is growing income first and life expectancy afterwards. The initial factories weren't a very healthy environment, but then so economy improves, pharmaceutical improve, life expectancy goes up. And there's some trickle down to the rest of the other countries as well for the vaccination program or health program that they benefit, even if they stay to a lower income until the 90s. And this is where, the 90s and the 2000s, China and India, of course, those two big blocks are China and India catching up. And that is good, if you want, because this is, life expectancy, and this is standard of living. And you can see on the right-hand side, the distribution of the population. We tend to think in binary mode. There is a developed country and developing country. Reality is always a bit more nuanced than that. And even, putting for discrete intervals here, we can, if you want, take 4 different standards of living. And the word we are familiar with is the one on the extreme right, level 4, which is, only 1 of the 7 billions of people on the planet. Each person there represents 1 billion people. And then, but that billion people produce that amount of emissions, which are the orange dots, and that you can also see on the spiky planet on the top left. So while there is a good story here of energy helping humanity progressing from the struggle to survive on the left to a better standard of living and health and life expectancy on the top right, there is a challenge which is coming with emissions. So the challenge is how do we then help those remaining 6 billion, and especially those 4 billion of people on the left, to get the same standard of living, but not the same emission level per person, and how can we reduce our emissions per person as well. And so, how bad is the situation with emission? Because, somehow it's good to move people there, but, what does it mean? So it is a pretty bad situation. We are currently heading towards about a 3 degrees increase. So that gray area represents, if you don't do nothing, we'll get into the 4.1, 4.8. But we are already doing a lot, or at least a lot of activity around the world. So that's not a credible scenario. But regardless, where we are heading at the moment is more around the 3. So the current policy is a scenario which brings it to a 2.8, 3.2 degrees increase in the global average temperature. And that is, by achieving the pledges, the policy and the promises made on the Paris Agreement. So more than that needs to be done if we want to get to the 2 degrees scenario, and even more if we want to get down to the 1.5 degree scenario. So last year, the IPCC published a special report on the 1.5, and that was very pivotal moment, I think, because there's a big difference between 2 and 1, and we're still striving to get to 2. We're not on the right direction for 2. But if you look at 2, and if you look at the slide or the picture at the bottom, that top bar in red, that's what happens to the various ecosystems of the planet when we reach 2 degrees. And what you can see there is, of course, risk, because this is not a world of certainties. This is a world of risk and probability and scenarios. But there's a very, very high risk at 2 degrees for a number of ecosystems and components of the ecosystem and industry, from flooding to crop yields and so forth, to be at a very stressful point, or very high level of risk. And 1.5, which doesn't sound a big difference, but at 0.5 degrees, actually turn a lot of those risks to a yellow, which is still risky. Well, it's not as bad as the full red. And so that's where we really should aim for. The challenge in doing so, and you can see that on the top right of the screen, is given where we are now, the amount of abatement, the amount of emission reduction that we need to achieve year on year is significant, right? So we need to reduce year on year by 10%. And if we start, if we start now, it's about 6%. Sorry, but if you wait 10 years, it will be 10% year on year, and that's not as easy as it might sound. But again, that is the 2 degrees, and instead we are trying to target a 1.5, which means that starting now, we require a monumental mitigation rate. And if we wait, we'll use, in 8 years, we'll use the remaining carbon budget. And the carbon budget is how much more the atmosphere can take of CO2 before having a big impact. And we need to remember that CO2 is a gas that once it is in the atmosphere stays there practically forever. As 100 of years, it doesn't dissolve. So there is that concept of carbon budget. So that tells us that it's highly likely that we're going to overshoot that carbon budget, which means that we need to find ways not only to abate and reduce emissions as much as we can and as fast as we can, but we also need to find a way to remove that carbon from the atmosphere and compensate, here around 2040, 2050, in order to then reduce that CO2 from the atmosphere and go back to 1.5. And so it's going to be not an easy path for sure. So then who do we have to blame for that? And the obvious answer that you can hear left and right, I'm sure, is well, the oil and gas industry, or the fossil fuel industry, to be more precise. And the Guardian even published the list of the 20 companies and the picture of their CEOs, pointing at them as these are the culprits. This is where emissions come from, which is at best a simplistic answer to the challenge, because in a way, the fossil fuel we have seen, they contribute to improve quality of life. They're a big threat now. But this industry has produced a commodity, that is driven by demand. And so this complex graph, which I guess some of you might be familiar with, on the left you can see the energy sources, and on the right the energy services that we use as people. And in the meantime, in the middle, all the transformation and the flow from those. So while it's clear that we need to start working quickly towards a world without emissions, and that means a world without or very limited fossil fuel in the picture, that means that we shouldn't focus only on the supply side, but we need to start thinking of the demand. And how do we change these services and the way the services are both received and provided, so that they use less of that fossil fuel, or if they do, they use less of that fossil fuel while burning and producing emissions. And so if you look at the progress being done, because the Paris Agreement are not yesterday's, they've been a while, but if you look at the progress that being done in the past 3 years, there are some good stories. Power in the UK is a very good story. The amount of emission generated by power generation, electricity generation, has went down a lot, and that is mainly to the investment in renewables, particularly wind, and therefore reduction of burning fossil fuel for power. what you can see here is also that many other sectors and industries that are contributing to the UK emissions haven't made that big of a progress instead. So let's have a look at this sector a little bit one by one, or by some clusters if you want. Let's start with power. I'm clicking. So if we start with power, as I said, that has been reduced significantly, and is going to do even more. What you see there is the Committee on Climate Change further ambition scenario telling us that by 2050 we will have much more electricity in the system, with doubling the amount of terawatt per hour that we're going to have in the system, and most of that will come from renewables, in the red part, mainly offshore wind. And part of the offshore wind sector deal that was signed last year, you can see here we're aiming to have a 75 plus gigawatt per year. At the moment, the UK has about 10 to 12 gigawatt, and it is one of the more advanced in the world in that sector. And there is, of course, a lot of wind on the coast of both England and Scotland. And more and more we're going to go into the what is called the floating wind, where the wind is stronger and more stable, but is also farther away from coast, requiring some different type of engineering and transmission systems. So, but that's a good story for power. When it comes to manufacturing, this picture represents how much the UK is emitting there, and the solution again from the Committee on Climate Change is telling us that hydrogen is a key element that will decarbonize manufacturing. Hydrogen combined with carbon capture and storage, and that's because for the next couple of decades, we probably need to produce a lot of blue hydrogen. So the difference is green hydrogen is produced with no emissions because it comes from electrolysis, basically breaking down water into oxygen and hydrogen. That requires a lot of energy, and if that energy comes from offshore wind, it is clean, and so that's green hydrogen. Blue hydrogen, on the contrary, is coming from methane and methane steam reforming or similar type of processes, in which one third of the product is hydrogen, 2/3 is CO2, and therefore it needs to be associated with carbon capture and storage. What you see before, the 75 gigawatt per year that we need to develop by 2050 is a lot of electricity, and that electricity is required by the electrification of the economy. And so not much is left for hydrogen. So that's why blue hydrogen is seen as a kind of a transition hydrogen source to provide that power to industrial, but also, I will say later, to heat, domestic heat, and potential transportation. And CCS needs to be a very big part of that for blue hydrogen, but also to decarbonize industrial clusters. The top picture is showing where the big industrial clusters in the UK, Anderside with 12.4 megaton per year, but also here in Scotland, Grangemouth and St Fergus as a cluster there with a lot of emission as well. And therefore, we're looking at solutions to capture that CO2, transport and store it, then underground in depleted oil reservoir, and therefore reducing those emissions. And as I said before, we have to start thinking also how do we take CO2 straight from the atmosphere. So there's a bit of a synergy here between the CCS for hydrogen, the CCS for industrial, and the CCS for balancing the offshooting of the carbon budget. But what you can see on the right, there's also a number of industries that are very hard to decarbonize, from cement and steel and petrochemical. And we need to also be careful that in achieving the UK emission target, that we don't achieve them by offshoring. That has happened in the past. If you look at the emission of the UK, they went down 40% since the 90s. But that's the amount of produced emissions. The consumption emissions, so the carbon embedded in the product that we use, it went down only 10%, because a lot of the production that was done, used to be done in the UK, now down in East Asia and in China, and then we import it back. So that's what Greta Thunberg talked about when she speaks about creative accounting for carbon. So the CCC recommendation and the legislation that the government put in place for net zero 2050 is clear that that is not part of the solution. So we need to decarbonize while keeping the industry here, not outsourcing it, which is good news for the economy, of course, because that's where you want to keep the jobs. So quickly through the transport, domestic heat and construction, other sectors here. So transport is clearly a big part of the emission world, and on the automotive side, it seems to be clearly steering towards a combination of electric vehicles, actually mainly electric vehicles, with hydrogen for some specific application. Particularly we're thinking of the return to base fleet, like buses, that we see in Aberdeen. There are 20 hydrogen buses in Aberdeen, which is great, and other similar application, and also having good vehicles that needs to do a lot of miles on a single trip, which would mean the battery would become so heavy to somehow become impractical. So it's a combination of electric vehicle and hydrogen. The jury is partially still out, but the car manufacturing industry seems to be clear on the EVs for private transportation, and hydrogen more of public transportation or big heavy loads. Aviation and marine are harder. Aviation in particular is harder because you need to have a lightweight, and the energy density in the traditional fuel is very, very strong advantage compared to batteries. But just today, I think the Prime Minister mentioned about that we need to invest and to develop an hydrogen aircraft, and some of the projects are already happening. We're looking at the small hopper between the Orkney Islands, looking at the technology using the hydrogen or electric vehicles for the short trip, and that is a starting point. But the longer haul flights are the target for that. Quickly through domestic heat, that's another area where waiting for the government-wide energy paper to clarify, but where the gas networks are going, all of them, from a Scottish Gas Network to Current and NGN and so forth, they're all investing in hydrogen-related projects. And the challenge there is how do we take hydrogen to the homes safely and efficiently and cheaply at the same time, so that we don't have an increasing cost for the consumer, but maybe we can reuse a lot of the infrastructure, because the alternative is electrification. But the gas network transport 3 times and 5 times is big time what the current grid can do. So there will be a need to invest in the gas network, to repurpose it and to make sure that it works for hydrogen. But there will be also a need to invest a lot into the grid if we want to go instead electric. So electrification will be mainly based on heat pumps, so when that is possible and doable. So they're going to be a bit of a mix, which is probably district-based and regional-based to start with, and then we'll probably evolve into probably hydrogen with heat pumps when it makes more sense. Hydrogen also depends on where the hydrogen is produced and how do we bring it from the production to the demand. So it might not be a one-size-fits-all solution, but that's where domestic heat is going, because domestic heat is a big part of the UK emission as well. And finally, construction, I mentioned before, cement is, but the construction sector is quite behind, and only now starting picking up and seriously looking at how to decarbonize and reduce the impact, which is both reducing the amount of CO2 produced in the production of cement, but also looking at the carbon negative material. So if we get to that direct capture and we can take CO2, maybe not necessarily storing to underground forever is the right solution. Maybe we can use some of that to produce material that store the CO2 for a long time. So the important thing is not a fizzy drink solution. It needs to be stored there for a long time so that it doesn't go to the atmosphere. And also looking at different ways of engineering and design, so design for reuse as opposed to demolish, and therefore reducing the amount of CO2 that goes into the atmosphere at the end of the useful life of the materials. So all this technology, where are we with this technology? So on the left, you can see a slide from the International Energy, not a slide, it is from the website of the International Energy Agency, the Clean Energy Technology Tracker. And you can see that a lot of that is not on track. There's a lot of red, and there's a lot of amber where more effort is needed. So solar PV went down a lot, bioenergy power generation, lighting, data centers. There are greens, and I updated this slide this week, and the previous one was actually for the previous implementation, which was in January. So in the 6 months, there's been some progress. Some of the amber turned green, some of the red turned amber, but something gone the other way as well. But this is the technology, and this is constantly changing in a way. But these are technologies that we need and we need to work on. And this is another technology that we know today. We're also looking at the OGTC, what are the potential game changers, which we won't wait for them, we need to act now, but it's cool and interesting to keep an eye on them because there might be something there that can change completely. So some of the things on the right are just some startups or initial companies that are getting toward the first prototype of their technology. And a couple of them are quite interesting when it comes to carbon engineering, for example. That's an example of direct air capture. It's extremely expensive at the moment, but then it depends, what the alternative is and what the cost of carbon will be at some point. But the challenge is how do we reduce the cost of doing that direct air capture, and similarly, how do we reduce the cost of transporting hydrogen, which is a gas that flows nicely in pipelines, but is hard in every other solution at the moment. And so looking at the solution to store hydrogen into liquid organic carrier or in ammonia, and then for long haul, which is what for example, doing in Australia when they're looking at a lot of potential to produce hydrogen in Australia and a lot of demand in Japan, and therefore transporting that hydrogen from Australia to Japan becomes a challenge that needs to be solved in a safe and in a reliable and affordable way. But some other, maybe a bit more strange initiative, but they're actually ready to start testing in Canada, which is at Proton Technology. There you can see Hygienic Earth Energy. That is about producing hydrogen straight from the field, leaving everything else behind, including CO2. And that can work also from depleted oil field, basically oxygenation to create the reaction downhole, downhole refinery in a way, that then generate the hydrogen and filtering when it comes out. So that would be also an interesting way of producing, which is not the blue and the green that we're looking at now. But keeping on technology today, there's been a lot of progress. A lot of this needs to be deployed, and therefore the cost will go down by economies of scale, economy of learning, but a lot also needs to be improved in order to become more reliable and affordable. So what then thinking? So that was the demand side. Now let's look at the supply side now. Let's go back to that list of oil companies or fossil fuel producers that we saw in the garden picture, if you want. This slide again is coming from the International Energy Agency, the report that was published, I think February or something like that, early in the year, before lockdown. Now we're becoming to the point where we distinguish things that happened before lockdown or after lockdown. Before lockdown, this report from the International Energy Agency actually showing the contribution on the estimated, scope 1, 2, and 3 greenhouse gases. I guess you all know, but just to clarify quickly, scope 1 are the emissions that you produce while operating your plant, your own operation. Scope 2 are related to the supply chain or the power that you take from someone else. And scope 3, which are the challenging one, are the consumption one. So when we produce oil or gas, scope 1 are the emissions at the platform and along the pipeline, and scope 3 are coming from our cars or our boilers and so on. And so, when you look at that, you see that even though the focus of the attention of the NGOs or the public sentiment tend to focus on the majors, on the big oil company, a big oil as where we put the finger. Actually, a lot of the biggest part of emission comes from the national oil companies and from the independent. And so I thought it was interesting to look at what are we doing as an industry, and looking at that from this perspective of segmenting this the industry in this way. And if we start looking at the major, just taking I know this is a superficial way of investigating if you want, but taking a screenshot of their website, and this is taken recently, so it's after COVID. And again, a previous presentation up there before COVID. But what you see is that despite the emergency of COVID and the impact of the oil price and etc., a lot of European, especially major have their energy transition program or strategy, or have energy transition on the front page. So you don't have to navigate much into the website to find it. The Americans, Exxon, Chevron, a little bit behind, and of course now there's a number of other dynamics like Black Lives Matter and other incidents that happen in America that are taking front page somehow. But they're also looking at that, that you have to navigate a bit more. They're lagging a bit behind, but not as much as you would think. When you look at the independent, the situation is different, right? So the independents, they are mainly focused on the return for the shareholder or for the investors. And you can just have a look at the website here. It's all oil and gas, oil and gas, oil and gas. So they are oil and gas company. On one hand, you can say, well, they tell you how it is. They are oil and gas company, and that's what they are there for. And also, we need to think also that there is an element of they're targeting a different audience with their website. So nobody goes on the Enquest Premier or Secret Point, or nobody in the consumer world goes there to see what they do. The investors go there, or the commercial partners go there, whereas the website of Shell, BP, and etc. are visited by consumers as well. But all that taken into consideration, is clear that the focus on the transition and the pivoting to the transition by the major is 1 or 2 steps ahead of the independent company, which are still focused mainly on getting the most out of their field. Therefore, there's a bit more of a risk here of being potentially unprepared by the transition and the decision that the policymaker will do or can do in that perspective. And finally, if we look at the third cluster of the national oil company, of course, this is still very much about their own country and how to provide welfare by taking advantage of the national resources. And you'll see more here about COVID as well, because that is part of keeping you see Petrobras here with the virus, and keeping their population safe and providing energy both to the country for their development and to export as a source of income for the nation. So what does it mean then for us in the UK continental shelf and the North Sea? And that is it a threat, this transition, or is it an opportunity? Well, definitely it is potentially a threat, because we're going towards net zero, legislation for net zero, the transition is happening. So there are cries for stopping exploration there. So there is a potential threat, because so much of the economy in this part of the world, but in the UK, depends on this industry. I think there's also an opportunity, though, because we need to shift the narrative and stop thinking about the silos. What you see there on the right-hand side is one of our slides. We call it the bubble chart, which is looking at what is the contribution to the economy at the moment of the various sectors. And we have an oil and gas industry which is still producing 24 billion of pounds for the economy in the UK. And a nascent offshore renewable industry that is about 2 billion for the moment. And of course, hydrogen production and carbon capture are non-existent, still waiting somehow for some commercial framework and investment. But that doesn't have to be the picture. We need to stop thinking in the vertical silos and start thinking of a systemic view. And so those oil and gas platform you can see on the top left, and those wind turbine on the top left, that are occupying very close space, but not talking to each other, not connecting to each other. Maybe there's a different way of doing that, and the different way of doing that is that are looking as a system, and the picture on the bottom left show a vision, what we call the integrated energy vision of the future, where there's an integration between oil and gas and renewables, to start with by using renewables to power offshore assets, because I forgot to mention before, but the oil and gas industry offshore emits about 16 million megaton per year of CO2, which is more than 100 side industrial cluster. And so we need to do something about that, because while we still need some oil and gas, we definitely don't need the emission from scope 1 production of that. So there's a way of looking at how can we use renewables to power up the oil and gas platform, but also how can we then produce hydrogen from them or from renewables. So there's that integration where the oil and gas industry has the potential to be the enabler, to be the industrial ecosystem that accelerates the development of an integrated industry in the North Sea. And that's somehow what we are working on in partnership with the renewable energy startup, for example, or other part of the economy and other sectors and technology sectors in looking at how that integration can happen. And so if we think about the future, the future for the basin is still a very good opportunity if we manage to embrace this transition and to make it happen. Because what you can see in 2050 there is the potential, again, this is no certainty here, but the potential to double the size of the economy, while at the same time we reduce the amount and the contribution to the economy and the amount of oil and gas produced on the left. So that's for the UK, but what does it mean for the planet? The UK on its own will not solve the problem. It is a global problem. Emissions, as we said before, when we talk about the outsourcing of production, don't really care about the borders of countries, and therefore shifting them around doesn't really help. So that's why this is a global challenge that needs to that requires a global coordination in achieving this. What you see here is the climate action tracker, and this again is updated in June. And I checked against the one I had here in January, and there's no change at all. So we're in the same situation, which is by itself not so good. What you can see is that no country can be defined as a role model. So no country is getting below the 1.5. No country contribution is helping achieving the less than 1.5 degrees increase. While Morocco is on the 1.5 compatible with a lot of investment in solar, and especially in reflected solar. And Europe and Canada, Mexico, Australia are in the insufficient area, with some highly insufficient and critically insufficient in the United States, Saudi Arabia, and Turkey and Russia, for example. So that's issue that somehow is not working perfectly, and more needs to be done on a global level and on a coordinated level. And that takes us to the road to Glasgow and to COP26 in November, which is a journey that started in 1992 with the creation of the UNFCCC, that is an organism of the United Nations that coordinated and created the conference of the party, the COP. That's what it stands for. The most notable of which was in 2015 in Paris, and since then there's been a bit of a failure, including last year. And high hopes were placed on COP26 this year, with the comments from the former president of it that the UK has one shot at the success of Glasgow COP26. Of course, since then things have changed. The pandemic has called for a delay, and now it's been confirmed that it's postponed by 1 year. So we're basically, writing off 2020. But that gives us potentially more time to do the right thing, and more time to prepare well, and to have a stronger voice from the oil and gas industry in the UK at COP26, enabling that transition and be a cornerstone, a building block for achieving climate neutrality by 2050, while at the same time keeping a healthy industry in the region. Because somehow COVID put everything a little bit of a pause, using the word of the boss of the International Energy Agency. When this crisis passes, the world economy will bounce back. Emissions must not, because emissions went down significantly. But remember that CO2 stays in the atmosphere. So the fact that they went down the emission doesn't mean that there are less of them in the atmosphere. They kept growing. And actually, the latest report, I think a couple of weeks ago, showed that we have achieved the highest, a new record in the parts per million in the atmosphere. And so, to conclude, and talking about the COVID, because we have to, how do we proceed after COVID? And the buzzword now is green recovery. But I think what COVID has shown in a way is that it is possible to put in place strong economic measures when there is an emergency. And on one hand, that we make it harder for government not to fund the net zero transition, given that it has been declared an emergency, at least in the UK and in many other countries. On the other hand, of course, it is still unclear how the economic impact of COVID will pan out. And we should remember that the world is not out of the pandemic. We're easing some measures in the UK, but that doesn't mean we're out of the pandemic. The virus is still there. And I think it was today that the World Health Organization warned that the worst has yet to come when it comes to the pandemic. So there's a word of caution there. But on the positive side, what you see there is the International Energy Agency published last week, I think, a special report on sustainable recovery. And showing that 1 billion a year for the next 1 trillion a year for the next 3 years can change the direction in 3 years, and that is 0.7 of the global GDP. So it's a big number, but at the end, not as huge as it might sound when you compare to the power of the economy, and especially when you look at the amount of measures that various governments around the world have put in place for COVID. So there is an argument there that it is possible, and what you see in the graph is the amount of jobs per million of spending of $1 million of capital that can be created if that is invested in a green recovery, which is a similar call that the CCC, the Committee on Climate Change, presentation to Parliament last week. At the end of the report, presenting on a report of emission, their recommendations are very similar. So using climate investment to support economic recovery. So let's recover from COVID towards the green, steering the economy to the green, and make sure that we don't bounce back in emission as well, which might be a challenge, and it will be a challenge, but it is nevertheless a possibility. And I think what we need to do as a sector, in preparing for this and in preparing for COP26 next year as well, is act on decarbonizing our operation first, and that integration with renewables that we talked about, that I was talking about before, and then embrace this transition, because there's a bigger role to play for the energy industry and for the oil and gas industry to be that enabler. And so I'm optimistic, although we need to work hard or we're in trouble. And with that, thank you very much, and I'm happy to see any question you might have at this moment.
Thank you, Luca. An interesting insight into our road to net zero, or to COP26. A couple of questions have come in, so obviously if you've got any more, please feel free to add them into the Q&A section. But to start us off, I think, as you touched on just in the latter part there around the whole impact of COVID-19, and not only have we seen that's had a positive impact on our emissions from a global perspective, but do we feel this could actually have a bit of a threat to the work that's been done to date, given that we are in a significant economic crisis globally? There will be a massive bounce back. Well, I think most of the governments are hoping for a big bounce back to try and minimise that recession, but that might come at a cost of, well, we can't afford to invest, or we will go with the cheapest, dirtiest, whichever way we can get our economies back on track. Do we have a risk of that? Or do we feel that we will stand by our statements that we will clean up our act?
What I see, what I hear is, there is clearly a need to help the economy recover. The numbers of April show that the lowest drop in the UK economy since the record began. So there's is not a marginal thing, and the oil and gas industry is also affected big time. So there is a need to bring people back to jobs, and probably the challenge of the tension is what is quicker and what has the most potential. And it seems that there's probably more potential in turning the economy towards a decarbonized world, which again is a transition, not a switch. I've said that I think this morning in another session as well. So we need to be careful on how to do it, but we need to do it as fast as we can, and that will generate a number of jobs that we saw from the slide from both report, but especially the International Energy Agency, that the number of jobs per $1 million of spending. So the question is, do we get more jobs in the traditional sector in oil and gas, than we get in the new ones. I don't think it is the case, but the temptation of doing that because that's faster could be there. So it's a delicate act. But I think from what I hear, narrative around government and various think tank and reports and organization, etc., is let's take this opportunity to create a green recovery as opposed of going back. That said, is the word of unknown, because as I said, the pandemic isn't over yet, and now we're going back to work. And of course, going back to work, what's the safest way to go back to work, if not your car? Public transport, not the safest place. So, but if you want to reduce emission and the amount of emission that went, how much they went down in London or in bigger city centers, cleaning up the air like never before. In Milan, well, I'm from Italy, of course. In Milan, the air quality has never been so good in the past 50 years. But once the economy starts recovering, are people jumping on the tube or taking their own car? So a big of incentive in the report from the CCC. You can see there's a bicycle there, not by mistake. Is cycling and walking a big part of the incentive scheme, and they're designing the urban territory as well. I think that there's a question mark for me, because this is all good now. It is summer. When it comes to winter, it might be a different story.
Perfect, thank you. A question that we had from Jane was really around the renewable targets and what mechanisms are required to ensure that we get back on track to meet those renewable targets.
Well, the sector of the renewable are going fast, to be honest, and the sector is still active. So I think the cost, in the end, is down to the cost of energy and the investment cost. The renewables, especially offshore wind. If you look at offshore wind, the cost of offshore wind came down by 50% since 2012. I remember because I co-authored a report in 2012 that was analyzing that, and it is now at that level when it's very competitive. Of course, what we need to do now is thinking of how do we make the same progress happen, the same cost reduction happen to floating wind, which is more expensive, but that's where we need to go to increase the power generation in the UK, and also to hydrogen and carbon capture. What mechanism, what commercial framework, incentive scheme, contract for difference, regulated asset base, you name it, can we put in place to make sure that industry somehow comes up and it is an attractive investment for investors. And the government is looking at that, is working on that. As I said, the white paper was expected this year, then it's postponed. It's likely to come next year or towards the end of the year. But I know there's working to be more comprehensive. But this is a combination of, to answer the question, sorry, maybe I went around a bit, but it's a combination of policy and technology, we think. On one side, we need to help with policy accelerating and drive investment in the right direction. On the other hand, and this is a technology-centered person speaking, we need to work on improving the technology, because part of that will come by increasing deployment. So economy of scales, economy of skills, we learn how to do things better and faster with the same technology. Part of that might come and should come from technology innovation. Some of the strange things I showed before, next to the technology progress tracker, are potential game changers. And electrolysis for green hydrogen is super expensive. Direct air capture is super expensive. So we need to find different way of doing that can change the economics and therefore making the policy intervention lighter than what it needs to be now.
Thank you for that. Question that's coming from James, which is really right on maybe the investment side as well, that we have touched upon. So do we see the private equity companies that obviously we've touched upon, will they shift their emphasis from the oil and gas shareholder returns and more towards the energy companies that are cognizant of their social license to operate? So a very topical one at the moment, I believe. So yeah, what's your thoughts on that one, on the investment portfolio community?
So I think it will. The the private equity is, the mid-sized companies that are backed by private equity are under enormous stress at the moment. The drop in the oil price and the impact of COVID have put a lot of stress into the system. And as you see before from the website, the key focus is showing that they can deliver, and keep attracting the investment. But the investment sector is interested in shifting a lot. So a lot of the funding comes from a pension fund or big investment fund, and those act in the interest of their shareholders, their contributors. And there's an increasing demand for the social responsibility, but the green credential of where the money is going. So more and more to invest in a company, the requirement will be to have a clear view, a transparent view of what that company is doing in terms of reducing their own footprint for Scope 1, and also in building a resilience for the future, for a long term. So there's a short-term action, which is recovery, deliver, efficiency, survival. There's a mid-term action, which is Scope 1 mainly. How do we make our emission zero? Or how we offset our emissions. And then there's long-term action, which is, okay, how are we part of the new world, of the new net zero world? These three action horizons are not discrete. You cannot start one and wait. I think we have to work on all three at the same time, but they're and as opposed to or strategies that needs to be put in place by these companies.
Also, just a bit of maybe going back to some of the discussion around the target dates. We've talked about COP26, which obviously has been delayed a year. So does that give us more time? And we've talked around the targets for 2050, and I know this was actually brought up in some of the sessions earlier today. Do we actually have to accelerate that? Do we need to go quicker, faster? But actually, when we do accelerate, if we can accelerate it, are we actually going to make the nodes that we need to? Because I think there has been a debate whether 2050 is too far, but would 2030, 2025 actually be achievable? And do you then get into a problem where you miss your targets?
For what I've seen and read and distilled in their own point of view, I think 2050 is a good and ambitious target. To be honest, and 2045 for Scotland is also a good and ambitious target. We need to go at the pace we can go, as fast as we can, but we need to be wary of unintended consequences. So there have been calls from various environmentalist organizations to stop producing oil and gas in the UK. If we do that tomorrow as a switch, the only result is that we double the import of oil and gas, because we are producing less than half of the oil and gas we use. And in a way, we can have more control on the oil and gas that we produce in terms of their emission that we have on that is imported. So I think it requires responsibility, and it requires that system vision that we cannot think of stop one and jump on the other. There's a lot of oil and gas still needed, although we need to accelerate the renewable, and we need to accelerate the hydrogen and so forth in order to make the transition and to make that oil and gas less needed, while at the same time the industry has shifted into a different mix. So yeah, I'm not sure to remember what the question was anymore, but hopefully I went somewhere there.
Yeah, no, it's fine. And I think it is, the whole 2050 it does seem a long way off. But I think there's a lot of people, including myself, think that to achieve something within that time frame is still going to be ambitious. And if we do it sooner, fine. But if we don't, then let's be realistic in that respect, which does sort of kind of maybe tie into a statement or a comment that Claire's made around the whole energy efficiency and maybe the quick gains. We talk in a lot of the headlines around hydrogen production and carbon capture and storage, but has that overshadowed some of maybe the initial gains around the 5 to 20% on reducing our CO2 without actually having to go into major capex projects? And do we need to be able to raise awareness of that? And how do we do that as an industry? Not only as oil and gas industry, but maybe just as the UK, can we start maybe looking at that in the short term? So do you think that's a challenge or something that is still being worked on, but maybe just not getting the headline it deserves?
It's probably a fair comment. I think not only we should, we have to. So energy efficiency, energy management, reducing the amount of energy we use, both on the platform, but in general, from the amount of energy we use in our home, if you want, and in our offices, is a critical part. And it is the simplest thing we can do right now. And it's something that is becoming also less and less of an option. We will see soon, I think, legislation or regulation in place and requirements to demonstrate that energy efficient is being pursued and achieved. The Oil and Gas Authority has a consultation out to embed net zero into the strategy. So the maximize economic recovery becomes a maximize economic recovery, or a new strategy with a new name, which includes net zero, includes strict obligation towards scope 1 emissions, and that comes in the short term from energy efficiency. What I would say is that is not enough. We've seen that carbon budget, we've seen that curve, how much we need to abate. So reducing the amount of emission that much, energy efficiency is not enough. But none of the components is enough. We have to throw everything and the famous kitchen sink to the problem if we want to be able to achieve a solution there. So yeah, hydrogen CCS are probably taking most of the headlines because they are big, complicated, and despite everything, not really started yet, and in need of strong and urgent regulation or commercial framework or policy intervention in addition to the technology. Energy efficiency is something we can start doing immediately, and we should.
So I think we're just about coming to a close, seeing as we're getting a bit later in the evening. I'm sure everybody's had a long, hard day at work. So just maybe as a bit of a closing statement or question to you would be, there's lots of actions out there and we have to prioritize, etc. So what would you choose to get the biggest bang for your buck?
Oh yeah, no. I won't fall into that trap because as I just said, it is a system solution and it is complicated. Yeah, but in terms of what we can do, we talk about industry, but we need to remember is an industry made of individuals. So maybe the answer is what we can do as individuals, and it is looking at our own footprint and is reconsidering some of the behaviors. We've been having this kind of conference and meetings for the past 3 months now, and there's been working effectively. So do we need to go back and travel around the world of the country every week or 3 times a week to do the same? Maybe we can reduce some of that. Do we need to use fossil fuel cars, or can we shift and buy the next car, a hybrid or an electric, or use the bicycle more, or maybe reducing 1 degree the heat in our homes and put a jumper on, or be more just cautious on how we use energy, because it is everything somehow counts. That won't be enough at all. Again, it is a combination, but we need to throw everything at it. So my recommendation would be, we need to think as an industry, and we need to think as individuals as well, because we are all part of the solution, both the industry and the individual. And I'll leave maybe with this slide. The previous one was the sources of all the graphs and data, so I didn't make any of those up. The kind of reliable sources. But maybe this is for whoever wants to dig a bit deeper into this topic and challenges. A selection of suggested readings. On the left, the top layer is a bit more, well, so far, is a bit more narrative, the reports instead on the bottom left, and some online training available for free or very cheap that I would recommend, especially the Penn State University Climate Change and Science and Global Impact, and also the carbon capture and storage from the University of Edinburgh, which I think has been part of the all of this has been part of the input for the presentation. But I'll recommend some of that if you fancy spending some of your private time and looking at these things. And with that, thank you very much for having me and giving me the opportunity to have this conversation. And I wish you all the best with the rest of the Energy Institute activities.
Thank you, Luca. And yeah, just one of our closing comments was, I think, yeah, as a government, not only a UK, but a global economy and global governments, we have been able to demonstrate that if we put our minds to it, we can change. COVID forced us to do things that we maybe weren't on the agenda, but now maybe we should learn on that and hopefully as a collective be able to start targeting some of these initiatives and putting some investment behind them. So hopefully that continues. I know that has been looked at from the UK side, so hopefully the whole global community comes together and learns on maybe the impact and some of the work they've been doing around the current challenges that we're facing. So thank you for your overview and your thoughts and sharing your time with us this evening. So for everybody else that's online, thank you for joining us. We will be looking to host more virtual technical sessions over the next few months, and hopefully we will be back face-to-face meetings in our normal programme in due course. So once again, thank you for your time. Any feedback that you have, any comments, or even any suggestions of any future topics, you can drop a note at the to the branch, and Katrina will no doubt come back to you with an appropriate response or take on board your suggestions. So once again, thank you for your time.
Thank you.